Okay, so good afternoon, everyone. Today will be our first chemistry class, and the topic will be two chapters. One is redox equilibrium. The second one is thermochemistry. Now, basically, what is redox? Redox. The RED here stands for reduction, and the OX here stands for oxidation. So redox is a process where reduction and oxidation happens. Okay, both happen simultaneously at the same time. Now you might ask me, what does it mean for something to undergo reduction, something to undergo oxidation? Well, there are four types of changes that we can use to define this redox. Okay, so the first one in terms of gain and loss of oxygen. So this one is the simplest one. Okay, oxidation, this word is like involving oxygen. So if something gains the oxygen, is called oxidation. Something loses the oxygen is called reduction. Okay, so here we have an example: magnesium with carbon dioxide. So you see, after the reaction, magnesium gains the oxygen, and after the reaction, carbon loses the oxygen. So magnesium undergoes oxidation, or is the oxidized substance, reduced substance carbon dioxide, which undergoes reduction. Now, how about oxidizing agent? Remember, oxidized substance, dia terbalik ya, equals to the reducing agent. Later I explain why is it like that. Okay, whereas the reduced substance equals to oxidizing agent. Dia terbalik. Don't confuse yourself. Okay, don't confuse yourself. Now, why is it called reducing agent? It's because, you see, look at the example. Magnesium is oxidized substance. Okay, so magnesium will cause the carbon dioxide to undergo reduction, because this magnesium, this oxidized substance, cause the carbon dioxide to undergo reduction. That's why it's called a reducing agent. Okay, same thing the opposite way. Carbon dioxide will undergo reduction to lose the oxygen, but because of this carbon dioxide, it causes the magnesium to oxidize. Okay, dia bagi magnesium oxygen. That's why it's called the oxidizing agent. Okay, can you understand? Okay, the second type is in terms of gain and loss of hydrogen. Hydrogen dia terbalik dengan oxygen. Kalau oxidation, dia oxygen naik, they gain the oxygen, but it will lose the hydrogen. Okay, reduction also terbalik, it will lose oxygen, it will gain hydrogen. So you see here, hydrogen sulfide with chlorine. So hydrogen sulfide, you see, it loses the hydrogen to form sulfur, so it's oxidation. Chlorine gas accepts the hydrogen to form HCl lah, hydrogen chloride. So it's reduction. Okay, so it's just opposite with oxidation lah. Okay, with oxygen. Okay. All right. So the third type will be in terms of electron transfer. Okay, this one will be a bit harder compared to the previous two, because this one is hard to see in the word equation like that lah. So oxidation reaction takes place when a reactant loses electron. When a reactant, okay, we use the example here. When a reactant, let's say your magnesium atom, you lose the electron. You lose, okay? That means become magnesium ion plus 2E minus. You lose kan. So dia jadi ion. This is called oxidation. Okay? You undergo oxidation, you lose the electron. Whereas for reduction, you will gain the electron. So oxygen plus the 2 electron from the magnesium, you will form oxide ion. Okay? Yeah. So this will be 4. Sorry. Okay. So magnesium undergoes oxidation because it loses electron. oxidation, oxygen undergoes reduction because it gains the electron. Okay, so this is in terms of electron transfer. The most common, how to say, later on you'll use in electrochemistry. Normally we focus on this one, electron transfer. All right. So yeah, and remember, of course, if undergo oxidation, that means this is reducing agent lah. Oxygen undergoes reduction, ini oxidizing agent lah. Okay, so I'm sure every one of you have already conducted the YouTube experiment. So you look at here, arm X and arm Y. Okay, so what is the result? Now, before you look at the result, make sure that it's connected to an electrode galvanometer, and then you must have your sulfuric acid as an electrolyte for the transfer of ion. Okay, remember, transfer of electron happens through connecting wire. Transfer of ion occurs through the electrolyte. Okay, now let's look at the observation and the result. It is found that the deflection of the galvanometer needle shows that there's a transfer of electron through the connecting wire from reducing agent to the oxidizing agent. Later we'll go in detail about chemical cell lah. But normally, like galvanometer, okay, your galvanometer, your needle will point towards the positive, because you see, if let's say this is negative, this is positive, your electrons will flow like this to like this to like this, right? So you see the flow, so the arrow akan ikut lah, the arrow macam tu, it will point towards there. Okay, so color change of solution also shows oxidation and reduction. Iron 2 sulfate solution, acidified potassium manganate are separated by an electrolyte with sulfuric acid. Okay, electron move from iron to ion to acidified potassium manganate. Okay, so let's see. Here you have iron 2 sulfate solution in arm X. In arm Y, you have a potassium manganate solution. So arm X, you will undergo the oxidation, because whenever you see iron 2, confirm it will become iron 3. Interchangeable one. Okay, confirm. You see iron 3, confirm in redox it will become iron 2. Iron 2, iron 3, iron 3, iron 2. Okay, so iron 2 akan menjadi iron 3. Iron 2 you already learned in form 4 salt chapter. Iron 2 is green color, iron 3 is brown color. Okay, so you see this one now is iron 2 become iron 3, so that means it release electron. So release electron is oxidation or reduction. Lose electron. Oxidation, yes, very good. Oxidation. Okay. And okay, manganate 4 ion, okay, receives the electron to form manganese 2 ion. So it's colorless solution lah. Okay, so what is the half equation? Okay, this substance is iron 2. The other arm, you have your manganate 7 lah. You have your manganate 7 ion. Okay, so like I said, iron 2 dia confirm akan jadi iron 3. Okay, iron 2 jadi iron 3. So you see, it gains electron or loses electron. Just now is 2 positive 2 charges. Now it's 3. That means you lose even more. So confirm here lah. So this is what we call a half equation. It shows the electron. It is the half equation. Okay. So Fe2 plus, Fe3 plus electron. Okay. Then you check also. You check balance or not. Fe, 1 Fe here, 1 Fe here. Balance. Okay. Here, left side, the charge is 2 plus. Right side, 3 plus, minus 1, also 2 plus. Can you understand? So this half equation is balanced already. Can you understand? Okay, Okay. Now you look at the other part. Here, release. Here, confirm accept lah. This one undergo reduction lah. So manganate ion, you have to remember what happens is, this is acidified. Okay, acidified manganate ion. Okay, MnO4 minus. Okay, no. Let's get that. Okay. MnO4 minus. Okay. Acidified maksudnya acid got hydrogen ion. Okay, hydrogen ion 1. You know will accept electron. Produce manganese, manganese 2 ion if I'm not mistaken. Is it called manganese 2? I think it's not stated here, but yeah, I think it should be called manganese 2 ion. And also water. Okay, you must have your basic first. You must know manganese ion, acidified, so confirm ada hydrogen ion, accept the electron, form manganese 2 ion, and water. Okay, in your head already, if all this listed, good. Then balance. Macam mana balance? Start with element first. Tengok, Mn1, Mn1, okay, balance. 4 oksigen. Oksigen 4. Sini 1 saja. 4 in front. Okay. Here, how many hydrogen? 8 hydrogen. Here, how many? 1. 8 lah. Okay. All elements balance already. Elements balance. Now you look at the charge. You have to balance the charge. Okay. -1 plus 8 minus 1 is berapa? -1 plus 8 is 7 lah. 7 minus 1, that means 6. Okay. Here here is 2 only. Okay. Did I do anything wrong? -1 plus 8 is 7. Yeah, -1. So basically you have to determine how many electrons here lah. Okay. So see, here is 2 and then 0. So that means 2 lah. Okay. Here is 2. Here is -1 plus 8. So this is 7 lah. So that means, what is it? 8. Did I do anything wrong? Yeah, correct lah. Okay. So here you see, -1 plus 8. Here is say is +7. Okay. Here +2. So how to positive -5 lah. -5 is here 5. Okay, can you understand? This is how you balance. Start with element, then you go to the charge. Is that okay? Can you understand? Or blur already? To -5 lah. -5 now, 5 electron lah. So now only the charge balance lah. Now, so what is the observation? The color change, okay? The color change is, this is green to brown. This one is purple, yeah? Purple lah. Manganese 7 ion is purple, manganese 2 is colorless lah. Okay, so these are the observation. Now, you have already 2 half equation. Remember, half equation is half, right? It's 2 parts, right? So when you have already 2, you can combine them together. Combine to form an ionic equation, okay? So reactants will of course be on the left side and product will be on the right side, okay? But first of all, before you combine, you have to look at the electron. Okay, before you combine, you have to look at the electron, okay? Here is 5. Here is only 1. So what to do? This first half equation, you have to times 5 lah. So that means 5Fe, okay, I draw a line on it. 5Fe2 plus, okay, only 1 reactant. Okay, then what other reactants are here? Plus MnO4 plus 8H plus, okay. Electrons you can remove already because it's the same, both sides same. Okay, okay. Okay, yeah. Okay, so this one ready. And then all the reactants habis. What is your product? Here also 5, remember. So 5Fe3 plus Mn2 plus 4H2O. So this is the complete ionic equation. And remember, in ionic equation, you don't have electron. Electrons only appear in half equation. Okay? Can you understand? Okay, Okay, I hope no one blur. Okay. Okay, so here are a few types of like oxidizing agent and reducing agent. Okay. Acidified are the hydrogen ion. You know it is an oxidizing agent. It will undergo reduction, so it will accept the electron. Okay. What will it form? It will form chromium ion, Cr3+. Okay. And water. Macam the manganate only lah. Just now the acidified potassium manganate, you just change this and this lah. So now dichromate also you change this and this. Okay. What you do first, balance upper dulu. Balance upper dulu. Element dulu. Yes, balance element dulu. So here you have okay, the potassium actually is the spectator ion, so I shouldn't write here, sorry. Potassium is spectator ion, so dia tak di dalam, okay? Okay, 2. Here got 2 chromium, here only 1 chromium. 2 lah. H, 2 here only 1. 2 lah. Okay? Then, no, actually I should do oxygen first, sorry. So sorry. Okay, 2 chromium, okay, 7 oxygen. So here H will be 14. Okay, elements done. Now you do the charges. Left hand side berapa charge? You calculate left hand side berapa? This is, sorry, I forget to write the charge here. Ayo. 2 minus. Okay. So 2 negative 2 plus 14, you will have 14 will be positive 12 lah. Okay. So the side berapa right hand side? Charge berapa? Two. Are you sure two? Two ah. Here already 3 what 2? Total charge berapa? Oh, okay. Others trying. Why only Eunice replying? You see everything also Eunice and then Hockey only say yes. Come on, guys. Jana, Abrina, Osman, Renjin, Shenjing. Lagging ah? Ayo. Ayo. Hey, if I lag, please let me know lah. Like where I lag or what. Ask me to repeat or what. Rian, can you all hear me now? Yeah, nothing is telling me lah. Let me check my line here. It says, where is it? Troubleshooting and help. Okay lah. Sometimes a bit that one. Okay. So come on. Right side. How many total charge? Hey, if you're slow, later we cannot even finish the class in 3 hours. Redox is very heavy, you know. Why 2? Why you all keep saying 2 charges? The charge here already 3 plus ma. This one is 0, right? This one is 3 plus. Okay. So what is the charge? Right hand side sini. Apakah charge dia? Left hand side is 12. Just now we calculate 12 already. Negative 2 plus 14. Positive 12. Right hand side. 3. Okay, are you sure it's 3? You look here. There's a 2 in front. Yes, good. Positive 6. So, positive 12. How to become positive 6? Minus 6 lah. So, where the 6 go? Electron. Okay? Understand? Can you understand? This is how we get for potassium dichromate 6 lah. Okay? Understand, yeah? Okay. Now, let's do one quick activity, okay? Let's use my agent. Reducing agent, let's say I put, okay, let's just do iron 2 now, okay? Iron 2 to iron 3, okay? Plus E minus. Now, I want to form an ionic equation. So tell me, what should I write? 5 Why 5? Why do you write 5? The elements correct already, but why 5? Last time 5. That means you don't understand lah. Why last time is why you write 5 lah. You sendiri go simply write 5 there. Others, what do you think? Yes, must balance. So why 5? Why do you write 5? I don't think so. I understand what you mean. This is one half equation. This is the second half equation. Now I want to form an ionic equation. So I need to combine both of them. So Eunice said, put 5 in front of Fe2+. Now I'm asking, why do you want to put 5? Yes, the answer is 6. Look at this electron. This is 1. This is 6. So to balance, this one times 6. 6 in front, not 5. Okay? Now, how about your product? Only 1 Fe3 plus? 6 Fe3 plus. Okay, so I think you all understand now. Okay. So now, let's just take a look at a few more oxidizing and reducing agents. Okay, so first of all, I want to say okay, why Cr, 2Cr here, copy from here. This one balanced already, half equation. This one also balanced already. But to combine both the ionic equation, you tengok the electron. Sini 6, sini 1. So sini times 6, you only get the same electron. Once you get ready, you can cancel. Then you only combine both together. Okay? Then you copy saja. Tapi ingatlah, ini you kena 6 in front here, 6 in front here. Then you only copy the entire thing. Okay, good. Thanks for asking. Thanks a lot. Please, you all must ask. Okay. Okay, so basically redox, you actually don't have to memorize like, oh my god, chlorine water is oxidizing agent. Okay, iron 2 sulfate reducing agent. You don't have to memorize like that. What you need to know is just, okay, chlorine or any halide ion, it will be, if you see chlorine as reactant, product dia confirm chloride ion. Okay? Bromine, bromide. Iodine, iodide. Okay? Just now Fe2 plus, Fe3 plus. It's always like this. If metals like zinc, confirm. You tengok zinc reactant, confirm product dia zinc 2 plus. What else? Okay, this one a few things you must know This one like okay, MnO4. This one you have to know This one will become Mn2 plus. Okay, Cr2O7 2 minus. This one will come Cr3 plus, and then like this. Okay, understand? So it's actually very easy only. You don't have to memorize. You see metal, confirm is the ion. You see macam ni. Bromide, bromide, bromine, iodide, iodine, like that. Okay, what else? Okay, sulfur dioxide is also a bit tricky Okay, sulfur dioxide, okay, it will become sulfate ion Okay, and one more, the acidified hydrogen peroxide, H2O2. Okay, it will become H2O Okay, but normally these are the few basics one you have to know. Okay. Okay, just now that one is all for electron transfer. How about oxidation number? Oxidation number, as the name say, oxidation. That means my oxidation number akan increase because it's oxidation number So you undergo oxidation, it increases Reduction, you reduce Okay. So how do we calculate the oxidation number? We have quite a few rules here. Okay, but you don't have to memorize. This one actually is very simple. You don't have to memorize. Okay, the first rule of oxidation number is that element 0. You tengok kalau dia atom, for example, sodium. Atom saja, right? Sodium is just an atom. So, oxidation number 0 Okay, no charge, right? Atom, 0. Okay, habis the first rule. Okay, second rule is, okay, let's say I ada charge, copper 2. So the charge is the oxidation number 2 plus. Okay, habis. That's all. Okay, number 3. Okay, so let's say you see. Let's say you know lithium. Lithium is group 1. So 1 plus the charge, lithium ion. Okay, that's all. 4. Sum of oxidation number of the element in a compound is 0. Let's say sodium chloride. Sodium chloride, you tengok. Dia ada charge ke? Outside here, the entire compound, is there charge? No, dia sudah neutral. Okay, dia sudah neutral. So, you see, sodium is +1, chloride is -1, so it's equal to 0 lah. Because the entire thing is 0 charge, mah. The entire compound. Understand? So it's just 0 lor. Okay? How about polyatomic ion? Let's say you have carbonate ion. Carbonate ion, the entire thing is -2. Entire thing -2. So the oxidation number -2 lah. Okay. Number 6. Okay, this one is a bit tricky already. So hydrogen ion group 1. So 1 plus except metal hydride. Metal hydride, okay, -1. What does it mean, metal hydride? For example, okay, sodium hydride. Sodium +1. So the hydrogen here -1. The total 0 lah. Okay, the 7th one. Oxygen, but it's the same as the 6, but it's oxygen lah. Okay, so oxygen except for hydrogen peroxide. Hydrogen peroxide H2O2 Cme +1, Cme were -1 lah. Okay, and yeah, group 17 like chloride, bromide, iodide, fluoride, all is -1 lah. Okay, can you understand? Do you understand all this? Yeah, okay. Actually, I think I confused you all already. Actually, it should be charge before number. Here, I think my mistake lah. I confused you all already. Okay. Ion charge, you kena tulis number and the sign. Tapi for oxidation number, you kena tulis sign dulu baru number. Okay. Okay, oxidation number. This is untuk ion charge. Can you understand this rule? Actually, it's not too complicated. You might think, oh my God, so complicated everything. But actually, it's nothing. It's just you go as usual according to the flow only. Okay? It's almost like similar to ion charge. It's just that it's called oxidation number lah, and then the total will be 0. Okay, can ah? So, let's do a few exercises. Okay, activity 1D, let's do a few exercises. Okay, let's do number 7. Looks very interesting. Vanadium kan? Okay, VO2 plus. O2 plus, okay. So this 2 plus is the entire thing 2 plus. So to find, now you want to find the V berapa charge, oxidation number, you letak 1x lah. Okay, 1x and then will equal to +2. Okay. Because the entire thing, the entire polyatomic ion is +2. Now, oxide, berapa charge dia? Or oxidation number. Why I keep using charge? Oxidation number. +2 or -2? -2. Okay, -2. So, x minus 2 equals to +2. X equals to +4. You must have positive. You tak ada sign sini, salah. You mesti tulis positive. Okay. So, we know that the V here, vanadium is 4 lah. Vanadium 4 oxide lah. Okay. Let's do one more question. Okay, let's do number 8. What is it lah? 8, right? There isn't a +2. Where? Oh, this one here. Okay. Let's say kalau sini tak ada +2 lah. Okay, x plus -2 equals 0. So, x minus 2 equals 0, x equals to +2. Okay, kalau tak ada ni charge. Okay, welcome, no problem. Okay, S8, sulfur 8. This is like, oh my god, very big molecule. Okay, berapa? Ni direct saja. I said already right, no charge. Atom macam tu, atom or molecule neutral macam tu saja. So, berapa? Yeah, you have to see lah. So, in this case is 0 lah. No charge mah, nothing mah, 0 lor. Okay. Okay, let's do one more question. Okay, last question. Okay, let's do number 4, HOBr. You want to find for bromine. Okay. So, total dulu berapa? Total. 0. Okay, because no ion charge mah 0 lah. Neutral compound. Okay, H berapa sini? Go by element, one element by one element, positive 1. O berapa? Positive 2 or negative 2? Negative 2. And your X lah. So 1 minus 2 plus X equals to 0. So negative 1 plus X equals to 0. So X equals to positive 1. Understand? So your charge for this bromine is positive 1. Okay, good job. So you all understand already lah, good. Okay, so I hope, okay, this one actually nothing, it's just that you have, oh wait, something important I want to mention here, okay. So that's all for the introduction to redox lah, the 4 types. Hydrogen, the oxygen, hydrogen, electron transfer, and oxidation number. Okay. Now, one thing I want to highlight for this page is people often like underestimate this, but this is very important. I'm sure all of you know, right? Iron 2, iron 3, everything. Okay. Let's say we have Fe. Fe apa? Okay, Fe2O3. What is the name for this? Fe2O3. Fe dia charge berapa? O dia charge berapa? Iron 2 oxide ah? Are you sure iron 2 oxide? Iron 2 trioxide? Ayo. No. Ini ionic compound kan? Iron 3 oxide, yes. Because sini Fe3 plus. Sini O2 minus. Interchange. This is an ionic compound. Interchange, so Fe2O3 lah. Okay. How do you write the name? Iron. Always start with a capital letter. Okay. Iron. This is iron 3. Okay. Iron, you have more than one oxidation number. That's why you must write the number iron 3. Okay. How? No space, bracket, capital letter 1, 2, 3. Capital letter for Roman numerals. Never ever write like this. Okay. Iron 3 space oxide. Sini ada space. The 3 belongs to the iron. So cannot have space here. Dia dekat sini. Iron 3 oxide. Iron 3 oxide. Okay. Jangan space. Sini mesti space. Ini capital letter. Can you understand? Yes. No, it's not style choice. Cannot small letter. You must be capital letter. Okay. You must have capital letter. Okay. And then here you cannot simply space or what. 3 mesti ikut dengan iron, separate from the oxide. Can you understand? For halogen, look at your periodic table, group 17. Halogen, the first thing is fluoride on top, okay? Fluorine. What else? Chlorine, and then you have your bromine, and then you have iodine, correct, right? As you go down the group, your electronegative, Vt, decreases. Okay, this is already your Form 4, Chapter 4. Okay, you go down the group in the periodic table. Thank you, Gerald. So, electronegativity decreases. Okay, so that means fluoride is more electronegative than chlorine, than bromine, than iodine. Chlorine is more electronegative than bromine and iodine. Okay, so how about this one? Okay, you see. Let's say satu test tube contains potassium iodide lah, for example, potassium iodide. I tambah bromine water. I add bromine water. Can it displace potassium iodide or not? Yes, the answer is boleh, because bromine water is more electronegative than the iodide lah, iodide. Okay, then iodide. The bromine is more electronegative than iodide. This iodide. Okay. Okay. Now, after you displace, normally we will add 1 trichloroethane. You will form 2 layers. What is this layer? What is this layer? What is the upper layer? Which one is 1,1,1 trichloroethane? Dah. Which one is 1,1,1 trichloroethane? Up or down? Up. Hiya. The answer is down. Okay, 1,1,1. I told you 1,1,1. I'm lazy already. Okay, this is aqueous solution. Okay. Why is it down? 1,1,1 trichloroethane is a covalent compound. It's very dense. It's very dense. It's very heavy dense That's why it will sink to the bottom. Okay. Up here is aqueous solution. What does it mean, aqueous solution? Basically, this one you mix with the bromine water. What is produced an aqueous solution? Okay, understand? Now, why do you add this? You add this is to verify the halogen present here. Okay, so how do I explain this? Okay. Okay, before we move on, let's do a few more exercises to see whether you really understand or not, can displace or not. Potassium bromide tambah chlorine. Boleh ke? Chlorine water into potassium bromide. Boleh. Good. Okay. Potassium chloride tambah iodine. Cannot. Potassium bromide tambah iodine. Tak boleh. Okay. So normally we don't do fluoride because fluoride is not in the lab, so tak boleh. Okay, one last one. Potassium iodide dengan chlorine water. Cannot. Are you sure cannot? Boleh. Okay, good. Okay, now so we can simplify in a table. You can simplify in a table. Okay. So, okay. So you have your chloride ion, bromide ion, iodide ion, chlorine, bromine, iodine. Okay, this one, of course, not possible because chlorine and chloride is the same thing. This one, no. Okay. Can bromine displace chloride? No. Iodine displace chloride? No. Chlorine displace bromine? Yes. Iodine displaces bromide. Sorry, displaces bromide. No. Chlorine displaces iodide. D'accord. Bromine displaces iodide. D'accord. Okay, yes, huh? So, okay, if yes, now you look at the yes reaction. Okay. Chlorine displaces bromide, you will produce the chloride halogen inside lah. Okay, sorry, you will form the bromine halogen inside. Okay, you see, for example, chloride, bromine can displace, you say yes, right? Can displace, so tukarlah potassium chloride and bromine and bromine lah inside, liquid bromine inside. So this one will be produced lah. Understand? So for chloride, chlorine lah, why I keep saying chloride? And iodine. Aqueous layer akan colorless. Colorless atau pale yellow. Very pale yellow. 111, the bottom layer, bromide is the ion, bromine is the element, yeah, is the molecule lah. Okay, so 111 dia akan yellow. Aqueous for bromine, okay, is brown. Aqueous for iodine is also brown. So you see, aqueous layer for both of these is brown. Bromine is just an element, yeah, correct? Element or also the molecule. So how do we differentiate these two? We have to add 111 trichloroethane lah. Add 111 trichloroethane untuk bromine sini akan brown. For iodine dia jadi purple. Can you understand? You have to remember here. Okay, which one can displace the product, and then you look what the color of the layers are. Aqueous, it will be all this. One, it will be all this lah. Yes, you have to memorize, but actually it's not hard. Eventually, you also understand the colors, right? 111 chlorine gas, you know, is greenish yellow, confirm yellow lah. Bromine gas, you know, brown, brown. No. 111 for iodine, purple. No. Nothing one. This one is just like purple for iodine, brown for bromine. Bromine gas is brown, right? So brown, no? Fe3 plus is brown, yeah, correct. Okay, let's try again. I rub off, then you try again. Maybe if I won't encourage you all to memorize this. You should memorize this first. You memorize this, you understand, then this one should be easy for you. Okay. Okay. Chlorine, you know, greenish yellow gas. Yeah, Fe2 plus is green. Chlorine, greenish yellow gas. If I add 111 trichloroethane, what is the color? Yellow lah, you know. Bromine, you know, bromine gas is brown. At this one, it shows its true colors lah. What is it? Brown, no? Iodine, you know the crystal, purple color, right? Your iodine antiseptic solution also purple, right? Purple lah. Then only you focus here. You ingat bromine, iodine sama, brown. This one, you look pale yellow also accepted already. Okay? That's all. Okay, so that's all for this displacement of halogen. Now, okay, let's look at baru the second subtopic. Okay, now you look at standard electropotential. This is already entering electrochemistry. This one actually you can read on your own basically. For our syllabus, your abang kakak, they learn the previous syllabus, they learn about electrochemical series ECS. But in our syllabus, actually our syllabus is easier, you know, because they give us the series already. We will learn about SEP, standard electrode potential. This is where the E0 value comes in. So scientists have already created this series to understand electrochemistry. Okay. Now, how do they form this series? Okay, how do they form? Okay, look. Electron potential is the potential difference produced when an equilibrium is established between metal and aqueous solution containing the M ion in half cell. So that means, okay, that means the difference between this positive and this negative will be the electropotential lah. So this is the electropotential, the value. Okay, electropotential berapa volt? Berapa volt? Okay, electropotential. Now, so scientists have developed a standard electropotential series. Okay, so that means, you see, okay, standard electropotential dia ada 4 condition. Dia mesti concentration of ions 1 mol per dm cube, gas pressure 1 atmosphere, temperature 25 room temperature, platinum kerana dia inert. So you use platinum as a half cell lah. Okay. So how do they, okay, later on. Okay, this one you don't have to really know. So basically they use hydrogen is akan 0 lah the volt. Okay, so how do they measure? This is a half cell. You see, okay, you look at this. This is a half cell. Okay, I have to draw lah, I think, so you all understand better. Okay, here platinum. Platinum ya, PT. Platinum. Sini hydrogen gas H2. Why hydrogen gas? Because remember inert value 0 volt for hydrogen gas. Okay, platinum kerana dia inert. What solution? Of course, solution containing hydrogen ion. Okay, so solution containing hydrogen ion. Okay, so this is a standard electropotential punya half cell. Okay, now sekarang voltmeter. Actually, it's not. Sorry, I draw wrong symbol. Voltmeter should be like this. Okay, voltmeter. Now, how do I determine the E naught of this metal? Let's say here, zinc. Okay, zinc. Okay, another half cell, salt bridge. Okay, zinc salt bridge. Ions here. Okay, so this one will contain the zinc ion lah. Here, if zinc here, mesti zinc ion. Okay, so I put the metal here connected to this. This is the standard electrode potential, SEP over here. Ini SEP. So I connect zinc to SEP. Voltage reading bagi berapa? Positive 0.76. So I know E naught value for zinc is positive 0.76. Sorry, negative. Can you understand? Can you understand how we get the E naught value? You connect to this thing, you get the voltmeter reading negative 0.76. That is the electrode potential lah. No lah, they won't ask how to get it lah. I want you all to understand first. Kalau you tak understand, nanti you cannot do the rest. Can you understand the concept of how do we get this? Can ah? Okay. Now, let's say kita, so this is the E naught value lah. So how they get lithium? Connect lithium here, this will get negative 3.04. Connect maybe what here? Okay, lead. If connect lead here, they get negative 0.13 lah. Okay. So you see, E naught, this SEP is arranged from negative until positive at the bottom. Okay, from top to bottom, most negative to most positive. All right. Now you look at the series. The one at the top has a higher tendency to undergo oxidation. This is your series now, okay? Okay. So this is the most negative, this is the most positive. So here it's easier, higher tendency to undergo oxidation. So that means oxidation how? Okay, you look at how it's arranged. It's arranged as ion lithium accept electron and then form the atom. So higher tendency oxidation maksudnya it is easier for it to go from right to left. Okay, you have to remember this. Okay, here positive, higher tendency undergo reduction. Okay, higher tendency undergo reduction. That means from the left to right, it accept the electron, go to the right, left to right. Okay, now oxidation is what agent? Answer must always be positive. That one is Enoch cell. That one is for the cell voltage, not the Enoch, not the Enoch here. The Enoch here depends on the metal, but Enoch cell later must always positive. Okay, later we'll have a look at that. Oxidation, what agent up here? Stronger. Okay, here higher tendency in oxidation can undergo oxidation. So what agent is this? Reducing agent lah. Okay, so here is higher tendency for oxidation. So from bottom go up, reducing agent stronger. Its role as the reducing agent stronger because it is higher tendency to oxidation, very easily oxidized. Okay, come down. Higher tendency reduction. Reduction is what agent? Oxidizing agent. Oxidizing agent stronger. Don't worry, later I'll teach you the technique lah. Okay, this is just a concept. You have to understand the series first. All right. So, if you understand this, that means okay lah, good ready. Okay. So, okay. Okay. Now the fun part come ready. Okay. Good. I love this one. This is where you can score. This part. Okay, now look at the situation. Okay, copper and silver nitrate. Okay, the question is asking whether this copper can displace silver nitrate. The first step you will do, the question will give you is the E0 value for the copper and silver nitrate. So you have to identify in the based on the E0 table these two things. So copper, you mesti ada copper and you mesti ada silver ion. Okay, E0 value. Okay, copper E0 berapa ya? Copper E0 positive 0.34. Silver E0 0.8. Okay. So, before I start, I want to ask, how is this arranged? Why is copper arranged above? Why? Based on the E0 value. Apa yang akan di atas? More electronegative? Not really say electronegative lah. Yeah, the one that donate higher tendency to donate lah. E0 value, okay, in simple terms, basically E0, you tengok E0 value. E0 value less positive or more negative akan di atas. Because remember, just now up here is negative, down here is positive. So the negative all will come out, positive go down. So sini copper is more negative, right? Or less positive kan? So pergi atas. Okay. When you arrange, you mesti arrange macam ni dulu. Negative on top, positive bottom. Okay. This is step 1. Can you understand? Step 1 here. Step 2, look what is present here. Copper and silver ion. Circle. Copper, silver ion. Okay. This one is in your head first. You don't, this one belum start to answer the question first. In your head first. You mesti ada dua ini. You mesti arrange properly. You mesti circle. Copper, silver ion. Can you understand? Then you see. Just now, the series. Right to left on top, left to right bottom. Is it correct? It starts from here, goes here. Starts from here, go here. Does it obey this? Does it obey this? Yes. If it obeys this, that means can displace lah. Okay, so in your head already, yes, this reaction occurs. So look at how does the textbook answer. This is your point already. Okay, your first point, E0 value of copper is less positive than E0 value of silver, which is 0. You don't have to say which is lah. So it's less positive than E0 value of silver. Okay. Copper is a stronger reducing agent compared to silver. Copper atom greater tendency release electron to form copper 2 ion. Copper undergoes oxidation reaction. This is the format. You mesti ikut to get all the marks. You mesti cakap E0 value. The first one, compare the E0 value of copper. Second one, stronger or weaker reducing agent. Third one, copper has a greater tendency to do apa? What the atom does. And fourth, what reaction? Oxidation reaction. Okay, 4 points for copper. Now, kita tengok silver. Another 4 points. Compare E0 value, stronger or weaker oxidizing agent, receive silver atom buat apa? Receive electron. What reaction? Reduction. Okay, and then displacement reaction occur lah. Can you understand? How do we answer this? Can you understand? Look at the second example. Copper and magnesium nitrate. First step, what should I do? First step. List down the half equation, the E0 value. Okay. So, siapa di atas dulu? Less positive or more negative lah. Okay, so magnesium. Berapa E0 value magnesium? Help me check. And E0 value, okay, copper here given already. Now, what you do next? What to do next? Compare, okay. What you should do next? Circle. What is present here? Circle. Copper sini. Magnesium ion sini. Does it obey? Macam ni, macam ni. Does it obey? Yes ah. Magnesium atas sini start from left. The top part supposed to start from right. Tapi sini start from left. Bottom part supposed to start from left. Tapi start from right. Cannot obey lah. Doesn't displace lah. Understand? Cannot displace. Displacement reaction doesn't happen. Can you understand? Okay ya, can ya? So you ingat, top part mesti right side, bottom part mesti left side. Start from left side, okay? Okay, so that's all for here. Now only we enter electrochemistry, okay? Okay, I want to go an express method. I want to compare both first, okay? I want to compare both fixed cell and electrolytic cell. What is this cell? How do you determine the E0 value of hydrogen gas to be 0 from the first place? Because that one they compare with the standard electrode potential lah. Yeah, like the scientists, they already determine that, okay, hydrogen memang kosong lah. Yeah. Actually, I also don't know how to answer that scientifically, but the basic explanation is they already did some tests beforehand. Then they just see, oh, okay, 0, okay lah. So they just use hydrogen as the 0 lah. Voltage is based off, yes, based off the standard, the SEP just now I draw one, the hydrogen gas as a standard, yes, hydrogen gas 0. Okay, now, this one, what cell is this? What cell is this? Voltaic. Good. What cell is this? Electrolysis, that's the process. Electrolytic. Okay, electrolytic. So, you tengok tak ada bateri, confirm voltaic dah. Ada bateri, confirm electrolytic. Okay, voltaic cell juga dikenali sebagai chemical cell or galvanic cell. It's the same thing. Chemical cell, galvanic cell, voltaic cell, semua sama. And there is another example, we call it Daniell cell. Tapi Daniell cell, you will only use zinc dengan copper, if I'm not mistaken. Betul kan? Zinc dengan copper. Okay. Daniell cell, okay. Okay. For voltaic, the two metals are different. Because voltaic cell, remember, just now the electrode potential is the difference between these two. Sini dengan sini. So the two metals must be different. Untuk electrolytic cell, two metals same. Two metals or electrode lah, okay? If both carbon, mesti carbon. Platinum, platinum. Graphite, graphite. Okay? Copper, copper. Okay. The next difference. How do I do this? Okay. You see, chemical change occurs here. Why is it called a voltaic cell or chemical cell? Because chemical change occurs here. Because of this chemical change, it will produce electricity here. The voltmeter will detect the electricity. That's why this one is chemical energy to electrical. Tapi sini berbeza opposite. Battery, electrical energy. Then conducts electrolysis here, causes electrolysis here. That's why it's from electrical to chemical. Can you understand? Okay, I repeat. Voltaic cell, chemical change here, produce current sini, electrical current. Sini untuk electrolytic cell, because battery ada electrical energy, it will produce electrolysis, electrical change here. Can you understand? Can. Good. Okay. Another difference. Two electrode, two electrode. Anode, cathode. Anode here negative, cathode positive. Anode here positive, cathode here negative. Okay, I know someone confirm already, or you complain already, confused already. Never mind. Basically, anode, they share the same feature. What do they do? Look at the word anode. A-N-O-D-E. A, anode. N meaning negative. For chemical cell, negative. O, oxidation. Oxidation occurs at anode for both of these. Okay, donate electron. So oxidation and donate electron always occur at the anode. Understand? Okay, later we have a deeper look at it. But can you understand this basic concept? Don't worry, my objective today is to make you like redox, because redox is one of the easiest chapter in chemistry. I have to teach until you all successfully suka redox. Okay, so let's look at the similarity. Electrodes are deep into electrolyte. They have electrolyte, that's a similarity. Oxidation reaction at the anode, reduction at cathode. Electron flow from the anode to the cathode through the connecting wire. Okay. So this one also I already explained. Okay. Okay. Now let's have a look at the chemical cell first. Okay, let's have a look at chemical cell. Okay. Now, how do you determine the anode and cathode? Chemical cell dulu. Anode and cathode, how do you determine? Which one negative, which one positive? Battery, voltaic cell, why suddenly battery? How do you determine which one positive, which one negative? Mana battery? We will look at the metals. Look at the metals. Compare the metals. Which one inert value more negative? Zinc inert value more negative. So this is the anode. This is cathode. Okay. Copper inert value more positive. So it's cathode. Can you understand? Okay. Can you understand? Actually, I tell you, voltaic cell is easier than this, because this one electrolysis you have a lot to learn. A voltaic cell is very ringkas only. Okay. So, you see here, give an example. You see, zinc is negative, copper is positive. That's why zinc is the anode lah, and the oxidation occurs here lah. Here is the cathode lah. So what happens? You see here, zinc. Sini copper. Okay. Oxidation occurs at anode. Okay. Oxidation occurs at anode. So zinc jadi apa? You remember that day I say, not that day, just now I say, zinc akan tukar jadi apa? Or maybe I should phrase it like this. Okay, I can draw again. Okay. Okay, zinc dia atas. Zinc, very good Eunice, thank you. Zinc is more negative, so dia atas. Start from where? Left or right? On top. Start from right, go to the left. So zinc produce zinc ion plus 2E minus. The bottom one, start from where? Left, yes, correct. Left. Go to the right. So copper 2 ion accept electron to form copper atom. So what happens? Sini zinc dia akan ionize, produce zinc ion dalam sini. Electron, dia release electron, right? Electron flow, come here copper electron. Okay, sini dalam sini ada copper ion. Copper ion accept the electron coming from the wire and form copper atom sini lah. Dia akan form copper atom. So the electrode becomes thicker. Can you understand the mechanism of this voltaic cell? Yes, good. Can you understand? Siapa blur? Siapa tak faham? Siapa sudah blur? That's why I say use the inert value. Always refer to your inert value, then can read. Okay, arrange, circle, then from where to where, and then here macam ni saja mechanism. Okay. Board blurry ya, cannot see ya. Can you see? Okay, so one last thing about chemical cell. One last thing is you have to know the how to write cell notation. Okay, cell notation. How do you write? You have to write macam ni. Okay, you tengok properly. Anode left side. Always start with anode left side. Okay, so what is the anode here? Zinc. Okay, zinc. One line. Okay, bye bye. Okay, you can join later lah after you makan. Okay, and then electrolyte, zinc 2+. separated by double line. Electrolyte, copper 2 plus. One line, copper. Can you understand? Left side anode, right side cathode. Mesti macam tu. Okay, this is how you write cell notation. And one last thing before we end this subtopic, calculate the voltage of the cell. E naught cell equals to E naught cathode minus E naught anode. So means positive 0.34 minus negative 0.76 means that 0.34 you will plus 0.76 and then your answer must be positive because your E naught cell cell voltage confirm positive. No, semua sini tak ada bateri. Ini voltage cell saja. We focusing on voltage cell, kita belum bagi sini tak ada bateri. Okay, depends on the metal and E naught value. Bukan bateri. Ignore bateri dulu. Sini tak ada bateri. Chemical cell tak ada bateri. Okay? Okay Can you understand? Can you understand this part, the E naught cell? Okay? So E naught cell, if you get an answer negative, that means you did something wrong. Maybe you use anode minus cathode. You should use the cathode minus anode lah. Okay Is everyone clear before we go to voltage electrolytic cell? Okay, electrolytic cell are your favorite lah. Okay, so depends on battery. Okay, battery long one is positive or short one is positive? Long positive, good. So based on this diagram, left side is positive or right side is positive? Left, good. Thank you. Left positive, right negative. So ini anode, ini cathode lah. Okay. Electrolysis is going to be more complicated because you have to learn the process, the factors and the process really. Okay. So electrical energy to chemical energy, tengok battery. Okay, tengok battery. Now, before we go into electrolysis, okay, first of all, you must know what is the meaning of electrolysis lah. Okay, process whereby compounds in a molten state or aqueous solution decompose into their constituent element. Okay, that means let's say inside here is copper 2 sulfate. Okay. Electrolysis means you decompose into its constituent element. That means I separate copper, I mau separate dengan sulfate. Okay? And then remember, because it's an aqueous solution, dia sebenarnya juga ada water lah. Okay? But we'll look into that later. First of all, you have to understand what is called an electrolyte. Mana dah? Okay. Electrolyte is substance that can conduct electricity in molten state or aqueous solution. Okay, so you see, you focus on 9 electrolyte first. 9 electrolyte means covalent compound. Covalent compounds such as glucose, water, what else? Acetamide, all these lah. Okay, all these covalent compound you cannot conduct electricity because it exists as neutral molecule only, no free moving ion. Okay. However, for electrolyte, it can be ionic compound or acid and alkaline. Okay, ionic compound in solid form, you cannot conduct electricity because this is chapter 5 from 4 because it's already attracted by strong electrostatic forces, no free moving ions. Okay, they're in the lattice structure. But if you heat up, it becomes molten or you dissolve in water, aqueous solution, then yes, because it has free moving ions. Okay, acid and alkaline, you all also know already, chapter 6 from 4. Presence of water. I kena tambah water baru dia boleh ionize to produce hydrogen ion and hydroxide ion. Without water, acid and alkaline no use. Okay, cannot conduct electricity. Can you understand? This is just the callback, just your revision lah for form 4. Okay. Now we look here. Okay, so conductor and electrolyte. Okay. Now, another difference between conductor and electrolyte is that conductor is the electrode. Okay, yang solid electrode itu conductor. Electrolyte is the solution. Okay, substances that conduct electricity in solid or molten state is conductor. Tapi electrolyte is substance that conduct electricity in molten or aqueous. Okay, so yeah, I think that's all. Metals and graphite, examples of conductor. Electrolyte is ionic compound and acid alkali lah. Okay, now let's look at the electrobromide. Okay, let's look at a simple electrolytic. No, actually, I don't think so. I want to teach electrobromide first. Okay, let's jump to. Okay, let's look at electrolysis, the factors. Okay. H2SO4, the separate two solution is H2SO4 and electrolyte. Yeah, it is. It is. You remember the YouTube? Just now we saw the YouTube, the arm X, arm Y punya in the first subtopic. Yeah, that one is electrolyte. Okay, now. Okay, now we look. Electrolysis. Okay, electrolysis. There are three factors to electrolysis. You must identify three factors. Okay. I hope you all remember. This one must listen closely. This one very important. Okay, electrolysis. Three factors. One is inert value. The basic punya always start with inert value. If got special condition, then only you look at second and third factor, which is the type of concentration, type of electrode. Do my best to explain now because I scared you all confused. I will do my best to ensure no confusion. Okay, anode, cathode. Okay. Okay. What ions is attracted to anode? Anode in electrolytic cell is positive, cathode is negative, but the ion, anode ions, anions attracted to anode, anions is negative. Ions attracted to cathode, cations is positive. Understand? So anions will attract because opposite that's why they attract. Anode is positive terminal in electrolytic cell. And okay, you anode, cathode, don't go and remember because you akan confused. You ingat saja anion dan cation. Anion N sini so negative. Cation you tengok the T here so is positive. Okay, so negative akan attract to positive kan, so the anode akan positive lah. Cations positive attracted to negative kan, so cathode negative lah. Can you understand? Now the first factor is basic inert value. Ini basic punya, no special condition or what. Look at anode. Okay, anode anion negative. Okay, so first of all, I need to introduce to you the term of selectively discharged. Okay, so you look at this example here. Copper 2 sulfate over here with H2O. Now, H2O, you have hydroxide ion and hydrogen ion. Okay, this is anode, this is cathode. Anion, negative ion attracted to anode. Okay, which is the negative ions? Copper, sulfate, hydroxide, hydrogen. Siapa negatif? Akan pergi sini. Siapa pergi sini? Anion. Siapa? Copper, sulfate, hydroxide, hydrogen. Siapa? Good. Hydroxide and sulfate. Copper 2 and hydrogen. Good. Okay. Both attract. They already attract. Two ions will be attracted. But only one can be selectively discharged. Discharge maksudnya from ion form, they become atom or molecule. Okay, dia buang charge dia. That's why it's called discharge. Selectively means dua pilih satu. Select kan. So selectively discharge. Okay. So how do you selectively discharge on the anode based on inert value, normal condition? Okay. Anion negatif kan, inert value mesti more negative lah. Look at your SEP table. Siapa more negative or less positive? Same thing more negative, less positive. Hydroxide dengan sulfate. Siapa more negative inert value? So the answer is hydroxide. Okay, hydroxide is more negative. Okay, hydroxide is more negative. For inert value of cathodes, the inert value, because you see cation ion is positive, so inert value more positive lah. So the answer here is copper. Copper 2 ion, the inert value more positive. Okay, concentration. The second factor is concentration, but concentration only applies for halide solution. What do you mean halide solution? Halide solution, that means chloride, bromide, iodide. Look here, sulfate. Is sulfate halide solution? No. If no, so that means you ignore this factor lah. Walaupun dia concentrated, tapi because dia bukan halide solution, ignore. Okay, tapi kalau saya change to halide solution, lepas tu dia concentrated. Why only halide is because it's a special condition lah. Is the inert value macam tu lah. Because the concentration of the halide solution is more of the halide ions. Okay, so concentrated halide solution baru dia akan tengok macam mana. Okay, so before I move on further, you have to understand all these factor sebenarnya cathode dia sama. Sama saja. Inert value positive, same here, same here. Inert value more positive, cathode akan semua sama. This factor only affects the anode. Only affects the anode for these three factors. Okay, so halide solution, kalau dia concentrated, it will release the halide ions lah. It will release the halide ions. Selectively discharge the halide ions because the concentration is higher. Okay. Now the third factor, type of electrodes, cathode is always the same. But anode, the electrode will ionize. Contohnya, I use copper electrode, dia akan ionize kepada copper 2 ion lah. Can you understand? Can you understand? Boleh ya? Okay. Okay, good. Okay, now let's look at examples. Okay, copper 2 sulfate. Okay, look. Copper 2 sulfate, which factor is this? Is it the inert value, type of electrode, or concentration? You look at the electrode, this is carbon, so it's inert. Which factor? This one. Senang je. The basic, right? Got special electrode meh? Got concentration or halide meh? Tak ada kan? So which factor? Yeah, first lah, inert value lah. Okay? So, like you said, the inert value, so hydroxide ion akan attract lah because inert value is less positive or more negative lah. For cathode is copper 2 ion lah because inert value more positive. So, in exam, they will ask you this type of question lah. Which electron attracted, which ion attracted, which one selectively discharged, and then you explain factor. Inert value more negative. Explain factor already. Then you say they will ask what is the observation, or they will ask you to write the half equation. Okay, after you write the half equation, observation. So you see, okay, hydroxide. Sini kita pilih hydroxide, sini kita pilih copper. Okay, hydroxide, you tengok apa akan berlaku untuk hydroxide. Okay, hydroxide, the equation, ingat in your head this how to say, mnemonic like that lah. 4 orang hutan minum 2 air, makan otak-otak dengan 4 elephant. I repeat, 4 orang hutan. No, Miss-Tan make that. 4 orang hutan, arrow, minum 2 air, makan otak-otak dengan 4 elephant. So you will release 4 electron, undergo oxidation, correct, right? So what it will produce? It will produce water and oxygen. Now, water is just remain here. But oxygen will release, the gas will release. So what is it? Colorless gas bubbles release. Understand? Colorless gas bubbles release. And then once they give you observation, they will give you inference. Inference, you can say oxygen gas release. And then how to test? Insert a glowing wooden splinter into the test tube. Now, before I move on, I think it's better I list it down. SPM, the question, what were they asked in electro for electrolysis? That's why I say it's the easiest to score, because this question cannot lari one. Confirm they will follow this one. Okay. The process in SPM is like this. First one, identify type of cell. Electrolytic atau voltage. Second, the anode or cathode. Anode, cathode. Third one, okay. Third one will ask you to say ions present or attracted. Fourth one, okay, selectively discharged. Half equation. Six, they will ask you what is the product. 7, observation. Actually, sorry. Okay, 6 actually is more to like the factors first lah, factor or explanation. Why you choose hydroxide? Okay. Lepas tu observation, lepas tu product or inference. Okay. 9 will be the verify or test. Okay. I give you one example. They give you this cell. Okay. I will repeat the same thing. They give you this cell. Type of cell, electrolytic cell. Anode, cathode, you identify. Okay, ions present, just now you told me already, hydroxide, hydrogen, copper 2, and sulfate. Okay, now they say, which one will be attracted to maybe anode? Okay, then you say hydroxide ion and sulfate ion. Okay, next question, they will ask you, which one selectively discharged? You must say hydroxide ion selectively discharged, and then you write the half equation. Okay, the 4 orang hutan, minum 2 air, makan otak-otak dengan 4 elephant. Okay, and then they will ask you to explain why is it selectively discharged. Then you have to know which factor to use lah. This one will be the first factor lah. Inert value of hydroxide ion is more negative than inert value of sulfate ion. Observation. What is the observation? Colorless gas bubbles release. Product or inference. What is the inference for this observation? The reason is oxygen gas release. How to verify? Insert a glowing wooden splinter into the mouth or the test tube. And then the glowing wooden splinter ignites, or you can say rekindles. Can you understand? SPM mesti tanya macam ni. Tak boleh lari. Like you see our trials that day, the paper. No, it won't. It maybe won't ask all these questions. Maybe out of this 9, it will ask 4 questions, for example. Maybe like trials paper that day, macam ni lah. They can only ask these 9 things. They cannot lari one. For electrolysis, can you understand? Okay, they can ask you selectively discharge, ask you write half equation, explain factor, verify test. Sini saja. That day the trials they didn't ask to verify lah. What else? They got ask you product. They got ask you what else? They didn't ask type of cell like that. Can you understand? Once you understand the entire thing, semua senang really. That's why I say this one Redox sangat senang. So please do more practice, okay? Don't understand, come and ask me, okay? But this is where you can score. You know this is hydroxide ion, sini senang dah. Hydroxide ion, explanation senang. Observation, you know oxygen already. You have to say colorless gas bubble, product is oxygen, and then how to verify. Okay? Process this later again, okay? Identify factor. Now we look back at textbook, okay? So, copper 2 sulfate solution, you see the process is the same thing. Ions that are present, copper 2, hydrogen, sulfate, hydroxide, okay? Ions move to anode, sulfate, hydroxide. Ion discharge, selectively discharge is hydroxide lah. Why? Inert value of hydroxide ion is less positive than inert value of sulfate ion. Okay, half equation macam mana? Observation to apa? Product to apa? Explain how product is formed. Type of reaction, oxidation. Okay. Now you look at cathode, also same thing. Copper 2, hydrogen ion present at cathode. Discharge is copper 2. Explain why. Inert value, copper 2 more positive. Half equation, observation, product, explain, what reaction. Can you understand? So you see, it's the same thing only. Okay? Okay, and yeah, that's all lah. Okay, then only we come to electroplating and this one lah. Electroplating. Electroplating basically means, let's say I use an active electrode. Let's say I use iron, for example. Or maybe you don't want to use iron, use copper lah. Okay. Okay. How do you determine anode cathode in electrolytic? Yes, look at battery. Electrolytic cell is always look at battery. So positive sini lah. Positive sini, negative sini. Okay. Positive sini, negative sini. Now you look. This one is this is an active electrode, copper. Okay, this is an iron spoon. Copper, active electrode. Which factor? Is it inert value, concentration, or type of electrode? Type of electrode, okay? Type of electrode, because it's an active electrode. So type of electrode only affect anode, right? Like I said, cathode is always only the inert value. So tengok what happens, type of electrode anode, dia akan ionize lah. So copper ion jadi copper atom become copper ion lah. Understand? So dia akan ionize, lepas tu dia attracted copper 2 ion, copper 2 sulfate. So copper 2 ion akan attracted kepada sini lah, kepada iron spoon. The electron datang sini. Lepas tu it will coat lah, it will coat the entire metal spoon. You understand? This is what we call electroplating lah. Can you understand? Okay, so you see this is electroplating lah. Yeah, basically this is electroplating. Okay, so what if I switch? What if sini positive, sini negative, macam ni. Spoon here, this one metal here. Can electroplating occur? No, cannot. Because this is the anode. Anode, supposedly metal ionized, tapi sini connected to the object. So cannot lah. Okay, so this is wrong lah. Okay, this is wrong. Now, purification is the same thing lah. It's basically here, positive, negative. Okay, so here you will have impure copper. And then here you will have your pure copper. What happens? Like I said just now, electroplating, because of this electrolysis type of electrode factor affect the anode. So here sini akan ionize. Okay, here akan ionize lah. This copper, the impure copper will have this, and then here will have the impurities. Down here will have impurities. Okay, over here will be impurities, and then all the copper 2 ion attract to here to form copper atom again. Copper atom. Okay, that is purification lah. Okay, now we go to rusting or extraction. Oh my god, a lot, huh? Okay, extraction, you just have to know the process in the blast furnace lah, and aluminium. So aluminium, how? Okay, you see mixture of molten aluminium oxide, and also they add sodium cryolite, okay, they add cryolite. So let's see how does the mechanism work. Okay, the mixture here, anode akan di atas semua tu carbon tu. Cathode is the one at the walls that carbon cathode, the layer. Okay, so molten aluminium will flow out. Okay, you see, aluminium is positive. Okay, it is a cation, it is positive. So when cation positive, it will attract to the negative cathode or the wall lah. That's why dia akan sink ke bottom. Lepas tu dia flow out, molten electron flow, aluminium flow out. Okay, whereas the oxide, everything will be attracted to the anode lah. Okay, so this is a hard equation, you can read yourself lah. Okay, another mechanism you have to understand, a process you have to understand is in the blast furnace lah. Blast furnace is for the iron lah, iron 3 oxide macam tu. Macam mana you get iron. Okay, so carbon di zone 1, I add carbon with oxygen to form carbon dioxide. Okay, in zone 2, carbon dioxide react with more carbon to form carbon monoxide. Okay, lepas tu carbon and carbon monoxide reducing agent, dia akan reduce the iron 3 oxide to iron. Okay, and produce carbon dioxide. Okay, so now I already have the molten ion, akan sink ke bottom and then I get molten iron lah. Tapi dalam iron 3 oxide ini, dia juga ada impurities macam calcium, macam silicon 4 oxide. That's why I will add calcium carbonate inside and then it will decompose to form carbon dioxide and calcium oxide. So the calcium oxide react with the impurities silicon 4 oxide to form calcium silicate lah, which is also something important lah, which is the slag lah, that we all also need information for marbles or all this lah. Okay, can you understand blast furnace? Blast furnace actually already explained in form 3 pun ada. Okay, so more reactive metal, basically this is a series. So very reactive metal we have to extract by electrolysis, like you see aluminium lah. But moderately, all this zinc until lead, you can use carbon to reduce the oxide lah. Whereas for copper and mercury, you can use by direct heating lah. And then the silver and gold exists as element in the Earth's crust lah. Okay. So what else? Yeah, I think that's all. So the last subtopic I think is rusting lah. Okay, so what is rusting? First, before we go to rusting, you have to understand what is corrosion first. Corrosion means that any metals in our daily life, it will corrode lah. Okay, exposed to the oxygen, to the air, it will corrode to form the ion. Okay, like magnesium metal, eventually it will corrode, oxidize lah. Okay, but we use corrosion for all metals except iron. Iron kita akan guna rusting, not corrosion rusting for iron. Okay, so now you see how does corrosion happen for iron. Okay, iron rusting, this is the process. Okay, listen carefully. At Roman 1 here, surface of iron in the middle is where the concentration of oxygen is low. Okay, because oxygen atas sini surface not bawah here. So this is the anode, negative terminal. This is a chemical cell. You know, iron rusting is actually like a chemical cell, the water droplets. So dalam situ is anode, which is negative lah. So at the anode, what happened? Iron become iron 2 ion and release electron. Okay, electrons flow through the iron to the surface. Okay, to the end of the water droplets where concentration oxygen higher. There is cathode lah, positive terminal reduction occurs there. Okay, and then oxygen dissolves in water to accept electron, undergoes reduction to form hydroxide ion. Okay, so half equation and reduction. This is terbalik. Just now is 4 orang hutan until all this, right? Now is terbalik. Is otak-otak minum 2 air dengan 4 elephant, then become the 4 orang hutan lah. Okay. The fourth one is the iron 2 ion react with the hydroxide ion produced to form iron 2 hydroxide. Okay, at first dia akan form iron 2 hydroxide. Lepas tu dia akan continuous oxidation to form iron 3 hydroxide. Okay, Rust. So, what is Rust? Iron 3 hydroxide lah. Okay. Okay. So, yeah, okay. So now you have to understand. I think, okay, no battery. Okay, bye-bye. So, how do you all do the half equation of oxidation? You all did this experiment, effect of other metals on rusting. So, metals, the iron nail, when I coil with other metals, you have to see siapa akan rust dulu, okay? So, dalam ini, in the test tube, in this experiment, I will have an iron nail, okay? And then I'll use a metal to coil around the iron nail, okay? Iron nail, metal, and then I will have hot agar. I will have sodium hydroxide and phenolphthalein. You have to understand what is the purpose of this sodium hydroxide and phenolphthalein first, okay? So, sodium hydroxide, it detects the presence of iron 2 and iron 3 ions, okay? Sodium hydroxide, iron 2 ion will be blue. Iron 3 ion is a blue pula. Wait, let me think about this. Sodium hydroxide, iron 2. Iron 2 is blue, right? Wait, that's copper 2. Wait, I am confused. Hold on, let me see. Iron 2. No, it's not sodium hydroxide. Yeah, that's why you see, no wonder I confused. Huh? Kenapa sih? Sorry, so sorry. Okay, not sodium hydroxide. It's potassium hexacyanurate 3. Okay, thank goodness. Oh, yo. Okay, 3FeCN6. Okay, thank goodness. Okay, so we talk about phenolphthalein first. So phenolphthalein, when this one oxidize already, it will produce hydroxide ion. So when the hydroxide ion, the phenolphthalein akan pink lah, because it's alkali mah, remember, alkali hydroxide ion, so phenolphthalein akan pink. Untuk ini, iron 2, it will produce blue. Okay, blue. The observation here, okay? So, okay, how do I explain? Okay, let's say iron. In the series, you have iron in the middle. Up here, maybe you have magnesium, aluminium, zinc, okay? All this on top, okay? And then lead, copper, silver at the bottom, okay? So, when I add this to the coil, what happens is it will produce pink spots. The one less electropositive than iron, blue spots. Pink spots meaning ada hydroxide ion, tapi dia tak ada iron 2 ion. Why? Because the iron doesn't corrode. In iron in contact with more electropositive metal, yang electropositive ini dia akan corrode dulu. Dia akan corrode and oxidize dulu to form like magnesium ion, aluminium ion, zinc ion, and also the hydroxide lah. That's why dia ada pink spots. Tapi dia tak ada iron. Untuk sini, iron is more electropositive than all this. So, iron akan rust dulu. Iron will become iron 2, will oxidize become iron 2 ion lah. So, dia akan ada blue spots lah. Tapi not pink because the hydroxide ion is already go here lah. Dia akan combine dengan iron 2 to form the rust lah. Semua ni belum corrode yet. Can you understand? I hope you understand here. Iron in contact with more electropositive, this one akan corrode dulu. Tapi untuk sini, iron akan rust dulu. Can you understand? Exam question. Yalah. Yeah, lah, this is typical exam question. Of course, rusting confirm, rusting 50% of the question for rusting confirm ask me one pink spot, blue spot. You understand? Oh my god, I'm so happy Eunice is still here. Xuanqing, Rian, I hope you're still here. Okay. Okay. Okay, so here's the ways of preventing. This one you can read yourself lah. Okay, you can paint to cover it, tin plating, chrome plating, galvanization. Sacrificial protection means you use a more electropositive to metal to sacrifice lah. Maksudnya dia akan corrode dulu. To prevent the iron from rusting, you letak a more electropositive metal like magnesium so that it corrodes first. That is a sacrificial metal lah. Okay. And then alloying, okay, you can alloy lah to prevent corrosion. Okay, habis redox. Can you understand redox? Okay, then maybe within half an hour you can finish thermochemistry already. Can you understand redox? Please, if you do understand, come and ask me questions, okay? And you can watch the recording if you're not sure for which part, okay? Because redox, understanding the concept is already 50%. You still, the other 50% is you still need to do exercises to expose to electrochemistry, all these different stuff. Baru you faham, oh, rupa-rupanya macam ni lah. Okay? Yeah. Yeah, I still cannot make you really like, but do a lot of practice, then you can, you will like it really. Okay? I can guarantee that. Because, I repeat again, you remember just now I write out all the 9 points. They can only ask you this 9. They cannot give you an essay for electrochemistry asking you kebab question. No. They can only ask you the 9 stuff, the product lah, half equation lah, semua tu. That's why it's very easy redox. Now, who can tell me what is thermochemistry? Okay, so heat lah. That means thermochemistry is something involving heat lah. So we have two types of reaction, exothermic, endothermic. Remember, exo, release macam tu, outside, release, exo. Endo is coming in. Endo means inside mah, so absorb the heat inside, okay? Endo. So, exo, you release outside. Of course, the temperature increase lah, will be very hot lah. Endo, because you absorb all the heat already mah. So the surrounding temperature decrease lah, akan jadi cold lah. Do you understand? Endothermic. So here are a few examples, okay? You have oxidation of metal is respiration, exo, neutralization, combustion, dissolving sodium hydroxide. Endo is like photosynthesis, decomposition of metal carbonate, metal nitride, dissolving ammonium salt lah. Okay. Now, okay. So now I have to expose you to what is called an energy level diagram. Okay, before I further ado, okay, before we go further, now I just want to ask, why exo release heat? Why do they need to release heat? Can anyone tell me, like, why do they release heat? Compare the energy value of the reactant and the product. Siapa lebih more energy? Break bond lah. You release heat to break bond lah. Release heat. Are you sure break bond? Release heat break bond itu endo. Endo break bond because you absorb the heat to break the bond, right? Remember? Exo is reactant above product. Good, okay. Exo means the reactant lebih tinggi daripada produk sini, lebih rendah. That's why you release the heat. Okay? Now, exo, you do it to form bonds. Endo, reactant lebih rendah, produk lebih tinggi. Okay? Because you have to absorb the heat so that you gain more energy and then you overcome. Okay, break the bond now, break the bond. Break bonds. Can you understand? Neutralization exo, yeah, because you see, neutralization, you form the bond, right? To form like sodium chloride or any salt. Okay, now, here is the fun part. In chemistry, we have two types of energy diagram. One is energy level diagram. One is energy profile diagram. Okay. Okay. Energy level diagram, energy profile diagram. Okay. This is an exo, this is for endo. Okay. Look properly. Energy profile diagram you have already learned in rate of reaction from 4 chapter 7. Okay. Energy level diagram you are learning in this thermochemistry lah. Okay. So the axis is always same energy. 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 Energy level diagram. Okay, first of all, exo just now you say is the reactant tinggi daripada produk kan. So you draw lah. Okay, reactant tinggi daripada produk. Reactant tinggi daripada produk. Reactant, okay, for endo, reactant lebih rendah because they absorb the heat to form the product. So reactant rendah, produk tinggi, reactant rendah. Okay. What is the difference between level and profile? You see level. Level is like staircase kan? One step, two step, three step, the level. Okay? So, it will form a direct arrow. Macam staircase macam tu. Okay? Ini staircase like that. Then horizontal like that. Okay? So, remember to draw arrow. Okay? Remember to draw arrow. Okay. Profile, you learn in the rate of reaction is the catalyst one. So, dia akan satu curve. Satu curve. The curve must be higher than this one. Must be higher because this is the activation energy for the reaction. Betul? Ingat tak? This is energy profile diagram lah. Okay, so I recap again. First of all, look at the reaction exo, you know the level. Draw out the level for the energy first, okay? Which one higher, which one lower. Lepas tu you tengok, if energy level diagram, staircase macam tu saja. Energy profile, you kena curve macam tu, okay? Okay, now, this is the activation energy in energy profile diagram of the reaction. But here, the delta H di sini, okay, is the difference of energy between the reactant and the product. Difference of energy between reactant and product. Okay, difference of energy means the heat absorbed or released lah. So the difference energy means here lah. Reactant dengan product sini delta H. Okay, sini delta H. This one I remember the trial got one question asking about this one, the delta H berapa. They give you these two and then they ask you compare something like that in paper 1. Okay, the objective question. Can you understand what I'm trying to say here? Yeah. Never mind, you get back a paper, then you look back. Okay. Can you understand what am I trying to teach here? Good, okay, good. Then remember to write your reactants and product lah. Reactants and product must remember to write reactant, product lah. Okay. Understand lah? Okay. So that's all for the diagram lah, for the graph. Okay. Now, finally Shenqing, thank goodness. Okay. So this one you can analyze yourself lah. Basic. Oh yeah, one more thing I forget to mention. You see, delta H, exothermic, you release. When you release, you like expel it out, right? You see, this one will decrease. So negative symbol, yeah. And endo, positive symbol because the heat increase you absorb you tambah so increase lah, the delta H akan positive. Okay. Now, once this, okay, this one also explained already lah. Okay. Now only you look at heat of reaction. So we have 4 types of heat of reaction: precipitation, displacement, neutralization, combustion. Now, tell me what is precipitation? Got precipitate, insoluble, good. Okay. Neutralization. Acid and alkali, something neutral, good. Okay. How about displacement? Something replaces something and produces heat. Okay. And that means like one metal I add into a solution, a copper 2 nitrate solution, to replace the metal. Okay. To become copper magnesium nitrate, and then I displace to get out the zinc. Keluarkan the zinc. That one is displacement lah. Okay. The last one, combustion. Okay, burn lah. Okay, so heat of all this heat of reaction, basically you just, when they ask you to calculate, you just have to calculate the Q and the mole. Okay, and then your final answer will be delta H, positive atau negative Q over mole. Okay, Q is MC theta. Mole, you calculate the mole by yourself lah. Understand? Yeah, fire lah. Okay, I repeat. When they ask you to calculate the heat of reaction, if you will take the heat, the Q, over the mole. Okay, Q equals to MC theta. M is the mass, C is specific heat capacity, always given 4.2. Mass is the volume lah. Okay, and theta is change in temperature. Okay, mole, calculate the mole amount of mole of substance, and then Q mole. Okay, delta H. Delta H will be positive or negative like this. Okay, now for precipitation, neutralization, and also displacement. Okay, the Q and mole is the substance, and the product or product. Okay, but combustion dia beza sikit. Q is water, mole is substance. Okay, what do I mean? Maksudnya, let's say I give you a chemical equation. A chemical equation is the substance. Okay, for precipitation, neutralization, displacement, the Q and the mole, all you get from the equation, the substance here. Later we look at the example, don't worry, okay? But for this combustion, only the mole you can get here. Let's say propanol, for example, you can get here. Water is, to get the heat, you refer to the water. What is the temperature change of the water? What is the mass of the water? Okay, later we have a deeper look in it. Okay, this is the basic. Okay, now you look at this. Okay, you look at this. Okay, so here are a few conditions. That means like already assumption that we have to take into account. So density of any solution is 1 gram per cm cube. That means 40 gram we assume is 40 centimeter. No, I go the other way around. Okay, sorry. Let's say your volume is 40 cm cube, so your mass will be 40 gram. Okay, over here. Okay, specific heat capacity 4.2. No heat lost by surrounding, no heat absorbed by apparatus. Okay, first one, heat of precipitation. You look, heat of precipitation, you kena hafal definition here. Okay, tapi, and then trial exam also got asked this question. Dia akan ada dua jenis. One, general definition. General definition means you can memorize this. Heat of precipitation is heat change when 1 mole of precipitate is formed from the ions in the aqueous solution. But the second one, which was asked during trial, is the specific. Based on the experiment or based on the activity, what is the definition of heat of precipitation? Kalau dia tanya macam tu, you kena specific. Heat of precipitation, like you look at the photograph 3.4, heat of precipitation is the heat change when 1 mole of barium sulfate is formed from barium ion and sulfate ion in the aqueous solution. Can you understand the difference? Specific dengan general. Okay. The trial exam, they ask the specific lah. Okay. So okay, like this. So they give you delta H already. Okay. Now, for example, you look at this example. 100 cm3 of 1 mole per dmq led to nitrate. Okay, right. Always remember to write down chemical equation. That will help you a lot. Okay. Led to nitrate, and then it's sodium sulfate. Okay. So they give you theta already. Okay. So calculate lead to nitrate, calculate the and then the sodium sulfate. Okay. Now you get the mole already, you buat mole ratio. Mole ratio, you tengok, you tulis the equation, you get all the same thing. So you know, you already got your mole lah. Your mole is 0.1 lah from this for this question. Okay? You already get 0.1 for the lactose sulfate precipitate. Once you get 0.1, then you calculate your Q. What is your Q? Your M. For the M, you cannot, because you see, precipitation is you mix both solution together. 100 cm cube plus 100 cm cube. So total 200 gram lah. C is 4.2. Theta, they already given you 30 to 33. So theta is 3 degrees Celsius. So your Q is 2.52 kilojoule. Okay, 2.52 kilojoule. Okay. Now, you have your Q, you have your mole. Now, you can calculate delta H already. How to calculate delta H? Divide, okay? Remember to write symbol in front because the temperature increases. It's an exothermic reaction, so negative sign in front. And then finally, will be in kilojoule per mole, the heat of reaction, precipitation. Can you understand? This one also you have to do a lot of practice. You cannot just understand theory like that. You have to do practice. Okay? Can you understand? Don't sleep. We are going to finish already. We are going to finish already. Okay? Okay. Then the same thing only. You see this one here is the same thing. Okay? So you can read yourself lah. Okay? Displacement, general definition, specific, you can faham 1 mole of metal displaced. Then the same thing only. Okay? Find the Q, find the mole. Okay? But you see here, the M, you don't mix together, right? You have one metal, you have one solution only, the solution only. So, you masuk ke dalam displace saja. You only have one solution. So, you tak payah mix the solution. So, you see here is only 50 cm3 lah, 50 gram lah. Okay? Find the Q, find the mole. Then you get your delta H ready. Okay? This is displacement. Neutralization, okay. Acid tambah alkali mix together. So your mass have to plus together lah, the total volume. Okay? 1 mole of water is formed. That means you need the water lah. Okay? Now, one thing I want to highlight here. Okay. You look here. Strong acid dengan strong alkali, heat of neutralization tinggi. Tapi you see, why when we use weak acid, weak alkali, it will decrease. This is the explanation. This one as okay. SPM, they will ask this kind of question. Why is it lower? So this is your essay. This can be asked in essay. You have to explain point by point. First point, weak acid or weak alkali ionize partially in water and remain as neutral molecule. Okay. Point 2, some of the heat released during neutralization is absorbed to completely ionize the weak acid or weak alkali in water. Okay. And the third point is heat release is lower lah. So this one you have to understand and memorize for exam lah. Okay. So neutralization also easy lah. It's the same thing. You see, calculate the Q, calculate the mole lah, and then divide to form delta H. Okay, that's all. Now combustion, you see, is different a bit because heat release when 1 mole of substance is completely burned in excess oxygen. Okay. Here you use the alcohol. Okay. Okay. Another thing they will ask in essay is that why when the number of carbon atoms per molecule of alcohol increases, the heat of combustion increases. So you see, as the number of carbon atoms per alcohol molecule increases, combustion of alcohol produces more carbon dioxide and water molecules. More heat is released. Increment in the heat of combustion between is almost the same because each one differs CH2 group. So basically you can say it's because it produces more carbon dioxide and water, so more bonds are formed, more heat is released lah. Okay. Now let's look at what is the difference. I don't really like this example, So because they already give you delta H, so let's say they want you to calculate delta H. They want you to calculate delta H heat of combustion. So for example, they give you the formula C2H5. Okay, ethanol lah, C2H5OH dengan apa? O2, 3O2, then you produce 2CO2. What else? 3H2O. Okay, they want you to find delta H. Now they say, okay, 200 cm3 of water is used. Okay, increase temperature theta is 50 degrees Celsius. Okay, mass of ethanol. Okay, let's say the mass they lose is 1.38 gram lah. Mass of ethanol. Okay, now how do you calculate? First of all, remember, delta H, you need the Q, you need the mole. So which one you do first also? Okay, let's say I want to do Q first. Okay, Q equals to MC theta. Okay, M, do I use this one or this one? Do I use ethanol or water? M, Rian and Shenqing.
Fuel is burn. No, sorry, you don't need this more ratio, I'm sorry. You don't need this more ratio, so this is the mole already. Okay, once you get your mole ready, then you can find out delta H equals to this Q, negative Q over the mole of ethanol. Understand? So you kena faham, you kena hati-hati, this one is used water, ethanol. Okay, so that's all. Okay, this is application, you can read yourself, thermite reaction, combustion, all this, sorry. Okay, last one, fuel value. What is fuel value? Fuel value, that is fuel.
Fuel is the amount of heat energy released when 1 gram of fuel is completely burned in excess of oxygen. Okay, 1 gram of fuel is completely burned in excess of oxygen. So the unit is kilojoule per gram lah. That means 1 gram I akan produce berapa kilojoule. Okay, so you see heat of combustion octane is macam tu, calculate fuel value lah. Okay, so they give you the heat of combustion already, you have to find the molar mass lah, and then you can only get the fuel value loh. So macam ni lah. Okay, habis thermochemistry. Do you have any question? No, okay. So thank you very much everyone for joining the class. This is a very long class because very heavy topic. So if you have any question, feel free to ask me anytime. So I look forward to seeing you all in the next class. Thank you and bye-bye.